All right, so we're continuing our discussion from last time about the systems of equations, and now we're looking at a couple of different methods to try and solve these systems of equations instead of having to rely on graphs every time. So for today, we're going to talk about the substitution method. And now we've been substituting numbers in for variables in the past, but now instead of just substituting in a number for a variable, we're going to substitute an entire expression. So the substitution method can be defined as a way of solving systems of equations by substituting or plugging in equations with one another. Now, I know that's a really wordy definition, but we're going to talk about each part of that a little bit more in depth when we talk about the step-by-step way to do that. So for our steps, the first step that we have is we want to solve one equation for either x or y. Doesn't matter which one, whichever you find the easiest is the best one to go with. Step 2 is to substitute or plug in the expression into the other equation and solve for the variable. The third step is to substitute again your answer into the revised equation from step 1 and solve for the other variable. So the first time we solve for a variable, we still have two variables in our equation, but we've solved for one so that we can plug in and solve for what that variable would be equal to. And the second time we substitute, we are plugging in for the first variable we solved for and then figuring out what number that one would be equal to. So let's take a look at this. There's a lot of substituting and solving. So the first thing we want to do is make sure that we can solve for either x or y in our equation. And for problem number 1, we have y equals 4x minus 1 and y equals 2x minus 5. Well, both of these equations are already solved for y. So that means that I can take this part of my second equation and plug it in for this y up here, giving me the new expression 2x minus 5 equals 4x minus 1. Now what I need to do is step 2. We've substituted in. Now I'm going to solve for the variable that I have. Well, the only variable I have in this expression, in this equation, is x. So that means that I want to get x all by itself. So my first step is to make sure that I get all of my constant terms, or my numbers, on the same side together. So I'm going to add 1, which gives me 2x minus 4 equals 4x. And then I need my x's to both be on the same side. So I'm going to subtract 2x from both sides of my equation. This gives me negative 4 equals 2x. And I just want 1x, so I'm dividing both sides by 2 to get x equals negative 2. So there's the first part of my solution. Now that I've solved for one variable, I need to take this and plug it into one of my equations up here. Whichever one you want to plug it into is your decision. I like to plug it into the one with the smaller coefficient for that variable. So I'm going to plug it into my second equation. Y equals 2 times negative 2 minus 5. Well, to solve for y, that means that I need to multiply and then subtract. So multiplying first would give me negative 4 minus 5. And then combining these two, negative 4 minus 5 would give me negative 9. So my solution for these two equations is the point negative 2, negative 9. Now, if you would like to, you can go ahead and practice solving these next couple of problems before I move on to the couple of next problem examples that we're going to do for today. As always, I'm going to post the key to our notes today in Schoology, so you can double check there to make sure that you have the correct answers for the day. But now we want to move on and do the next couple of problems. So the next problem we're going to do is problem number 7. We're going to do problem number 7 next. And remember, our first step to solving this is to make sure that we solve for one of the variables first. And when I compare these two equations, I notice that this x is already just one x. So that tells me that this would be the easiest variable to solve for first. If I do that, that means that I need to get x all by itself. Well, to get x by itself, that means I need to get this y to the other side. So I'm going to subtract 5y from both sides, and I get the expression x equals negative 5y plus 4. I've solved for one of my variables. I have x equals, so I'm going to take this expression here and plug it in for x up here. So that's the first part of step 2. So now I have 3 times negative 5y plus 4 plus 15y equals negative 1. Well, the first part, in order to solve for my next variable, I have to get y by itself, which means that I need to distribute this 3 to both parts of this parenthesis set. So if I take 3 times negative 5y, I get negative 15y. And if I take 3 times 4, I get plus 12. And I have plus 15y, and that equals negative 1. The next step would be to get this 12 to the other side so that I have my y's on one side and my constants on the other side. So I'm going to subtract 12 from both sides. That means that my new equation says that I have 15y plus 15y equals negative 13. So if I have negative 15y plus 15y equal to negative 13, well, I'm going to combine my like terms. If I have negative 15 plus 15, these two actually simplify down to 0 y's equal negative 13. Well, if I have 0 y's, that means that there are no y's in this expression anymore. When that happens, that means that these lines are actually the same thing. I can show you that by taking our expression here, our second equation, and if I were to try and solve for x in this equation, we would get almost the exact same expression. So I'm going to do that off to the side here. So if I take 3x plus 15y equals negative 1. Well, if I want x to be by itself, just like I had for over here, then I want to subtract y to the other side. So minus 15y to both sides. So now I have 3x equals negative 15y minus 1. But I don't want 3 x's, I want just 1. So I need to divide both sides by 3, which gives me x equals negative 5y minus 1/3. Now remember, parallel lines don't have the same intercept, right? This last number is not the same. So this tells me that I have x equals negative 5y plus some number, and x equals negative 5y plus a different number. That means that these lines never intersect because they are parallel. And when we have parallel lines, that means that these are no solution. We have our 0 with a line through it. They never intersect, so there are no solutions. Last example I'm going to do for today is example number 9. For example number 9, again, we want to solve for one of the variables in our expression. And again, I'm going to solve for the easiest one that is already by itself. Well, we have 1y in our second equation. That tells me that I am going to want to solve for y in this second equation. So if I have 2x plus y equals 18, and I want to get y by itself, I'm going to subtract 2x from both sides. This now gives me y equals negative 2x plus 18. And since I have y by itself, I can go ahead and plug it into my first equation. Moving into step 2 now. So now I would have 6x plus 3 times negative 2x plus 18. It's got a little smushed in there, but that's okay. And that equals 54. Well, again, I need to distribute this 3 to both terms in this parenthesis. And if I take 3 times negative 2x, I get negative 6x, and 3 times 18 would give me a positive 54. And that equals 54. Now again, before I start combining like terms, I want to make sure that I have constants all on one side and my x's all on the other. So let me move this 54 over, minus 54 from both sides. Well, 54 minus 54 would give me 0. And if I take 6x minus 6x, I get 0x. In this example, I get 0 equals 0, which is different from what I got in number 7. I had 0 equals a number, which is just not a true thing to say. However, I have 0 equals 0 in this expression, which tells me that these two lines have to be the same thing. Again, I can show that by solving for y in this first equation up here. So if I take 6x plus 3y equals 54, and I solve for y, I should get the exact same thing that I have over here. So I want y by itself. I'm going to subtract 6x from both sides. I get 3y equals negative 6x plus 54. And I don't want 3 y's, I want just 1. So I need to divide both sides by 3. And I get y equals negative 2x plus 54 divided by 3 is 18. This is the exact same thing that I had over here. In other words, these are the exact same equation. And when we looked at our examples of the types of solutions that we have, when we have the same line, that means that these have infinitely many solutions because they're the same line. For today, your assignment is in Delta Math. As always, if you have any questions, please send me an email, send me a message, reach out and make sure that you get those questions answered. See you later.